Hello, I'm Landis. Welcome to my studio. Hi, Ron here. We're continuing our series on making finger picks, and Timothy will be describing rolling out the material that he's cast in the last 2 episodes and annealing that and what that goes to. Have fun.
So just using this one as a knockdown, and I take really small bites. I'm really kind of just trying to get it down to a thickness that'll fit down into my finishing mill. So as you work sterling, it becomes work hardened really easily, and you're going to get crazing and cracking and all kinds of trouble in your material if you don't keep it annealed and keep it soft while you're working it. Fine silver doesn't have that problem because it stays constantly elastic. There's very little need to anneal pure silver while working it, especially in the being as heavy-handed as we are with our rolling mills and stuff. We're taking such a reduction ratio. We're really creating a lot of pressure and a lot of stress inside the material, and so for fine silver we have very little need to anneal it during processing. We do anneal the blanks and blanch them before striking and things like that, but with sterling it's important to constantly keep it annealed. I can't stress it enough, because what happens is the part will start to crack. You'll get cracks and crazing and all kinds of trouble all over the material. It won't stay flat. It's just a total pain. So what we do is we're actually just using a propane torch to keep this. We're gonna heat this up red hot, and then we're gonna quench it in an annealing bath that has some acid. Again, we do kind of low tech here, which is really fun. Because in a production situation, in a larger mint, you would use an actual annealing furnace, annealing oven, which is similar to like the pizza ovens you'd see like at your Pizza Hut or something. It's a belt furnace. But in this case, we're working with 1 bar. We can heat it up in the propane and do everything we need with the torch here. Again, in production situations where you're making parts with tolerances for specific customers, you can measure and adjust all kinds of temperatures and hardnesses, and those can all be measured, and we're capable of doing all that. But for what we're doing, again, the final product, we know from experience just what we need to do to get to that point. And since our end user is the literal end user, the customer, we're not making this as a tolerance or a specified part for a person. We're able to kind of, live in that gray area, which is part of what makes it so fun to work here rather than someplace that is so strictly adherent to, other people's tolerances and other people's clearances and specifications. We're extremely tolerant here.
Two hours later.
That plum color is plenty. The nice thing about precious metal is it conducts heat really effectively. So we know that the temperature is consistent throughout the entire bar. Different materials and different densities, they conduct heat differently. So there's certain soak times and temperatures that you have to use to make sure that the entire thickness, all the material actually reaches the hardness that you're after. But again, with precious metals, they conduct heat so well, you can be pretty certain that once it's up to that color, that it's pretty much that temperature through the entire bar. I mean, on a molecular level, there's plenty of argument for that. But again, for what we're doing, this will work fine. Now we'll throw it in this acid. And now you can see that it took on, still got a little temperature in it. Shocking. You can even see some of that cracking. Maybe not in the camera or not, but I'll take this over to the wire wheel and we'll clean that surface up again, and then we'll hit it in the rolling mill again. Okay, so depending on what kind of product you're making in your rolling mill, it's really important to keep your rolls as clean as possible. Most of our products are hand finished, and even our coins, we tumble them and clean the blanks and everything before striking. So we're actually able to get away with, you're not going to find our rolls here as clean as somebody who's making like a high-end finished roll product. There's some products that people are making using rolling mills where, yeah, you need the surface to be as clean as possible. The finished surface coming off those rolls is actually the end surface texture or finish that you need. Like I said, most of the stuff we're making here, we hand finish or we finish the blanks before we actually strike them. So, but regardless of that, we still want to keep the rolls as clean as possible because you're going to get grease and deposit, and as they sit there when you're not using them, there's dust, and you don't want any of that on there because anything that's on that roll is going to get imprinted or pressed into this surface. So you do want to try and keep it as free as debris as possible. So what I like to do is I just take a little bit of acetone on a paper towel, and I get it nice and wet. Soaked, and I've got a paint scraper, a palette knife, and I turn the mill on. I've got the mill closed to where this won't fit through there. This is the exit side of the mill. Don't ever do this on the entrance side because all it's going to do is suck it up in there and you'll have all kinds of problems. So what I'm going to do is I just have that acetone on a paper towel and I can place it and I can push pretty hard and just let the rolls clean themselves. If you need a higher finish, you can take some diamond paper, some sheet, or even some diamond paste if you have a high enough finish, and you can do the same thing. You can just let the rolls do the work. You see just the dust and grease that collects over time. Let's fold it up again and just keep doing that until I got it as clean as I need it. It wasn't this mill in particular, it's one of our smaller rolling mills. I was actually working with breaking down material to get it small enough to fit into the caster again, and kind of just not paying attention. And the material, many of you who have worked with rolling mills know that the material can wave a little as it's going in and out. And as I was feeding the piece in, I was too close and it waved down and it grabbed my finger and it actually tore and pulled my finger into the rolling mill. You can see my pointer finger there is severely distressed. It's my Frankenstein finger. And it actually took about 3 surgeries to put it back together. And that's only one of the finger injuries I've had over the 20 plus years doing this. They call me Fingers because I still have all 10. Now that it's all cleaned up, we'll just open it back up to the thickness that we get to start here. So. And we'll just start the process of knocking this down. Every time it passes through there, we turn it down a little bit. pass. Oh, this is kind of cool. To start, when that bar was cast, it's already a little longer. It was probably 8 inches when we started. And you'll see by the time we get to the thickness we need, you'll see how long it gets. See, I'm actually taking the time to flip it each time too, because what's happening inside the bar is there's a grain structure in there. Like under a microscope, it would look like oatmeal, and what it's doing is it's elongating all of that grain and stretching it all out. And if you keep doing it in the same direction, you're going to get, like on a molecular level, literally, the crystals are going to be all pushed in one direction. And when you flip it, each time you go through, there's a lot of room here. Again, you can get real technical, and if we were making, replacement medical parts or something, you really have to be that precise. But again, for what we're doing, there's a lot of room, there's a lot of tolerance. And what you're trying to do is just make sure that as you're running it through there, that those crystals are rolling in all kinds of different directions. Because what you want is a nice consistent density as it goes through. And that will help relieve some of the cracking that can occur and things like that as you move through the further processes. So it's just good to keep the material, and it's funny because every mill kind of has a signature in terms of how it likes to have the material processed. There's always, you can do everything you can to get those parallel, but if the bar was cast with a slightly thick side, or even one slight hair is higher on one side, the bar wants to go all kinds of weird directions. Every mill has its own little signature, and you just kind of find it and move that material around, and make sure you're just moving that grain around as much as possible. Information overload. That's what I'm good at. Like all good art, you spend your life learning all the details of all the techniques, only to return to more simple methods. Boy, does it start to get warm. You can see we're already to a foot off of 8 inches, so we got a long way to go. I'm actually going to anneal this again, because you can see I'm starting to get some deformation in there that is a little bit more than I like. And so I'll anneal it, clean it up, and we'll keep going.
A few inches later.
Okay, so I've already rolled this down and annealed it, cleaned it several times, even to the point where I cut the strip in half, because it gets too long to handle. And you can keep it that long if you want, but just for convenience, we cut it down. So we're already to about 4 feet long off that 8-inch strip. We're down to about 100 thou right now, almost exactly. We're going to go down to 0.052 inches, or we say 52 thousandths. And that started off as a really thick strip, and we go down really thin, and it's really just for convenience so that I can get it in one bar and move it a lot. But from a purely technical or engineering perspective, when you're rolling your precious metals, your silvers and stuff, if you want to get a consistent density and a consistent grain structure, so that when you're annealing and working the material, and it stays, so you can get rid of voids and inconsistencies within the material, you want to aim for at least 40% reduction rate. So you want to start at a thickness and reduce that thickness down by at least 40%. Obviously we've gone from, 3/4 of an inch all the way down to 0.052. So we've gone plenty over 40%. Right now we're going to head, I know that this wrench thereabouts gets me about 20 thousandths. I'm at 100 thousandths now. So I'll run it through there a couple times until I get real close, and then I'll start measuring with my micrometer to make sure I use the exact thickness that I need. I'm probably somewhere around 60. I'm actually at about 65 and a half right now. I'm aiming for 52. Now, if I was working on a coin, it's very important to get just as an exact measurement as possible because it's going to determine the weight of the piece. But what we're doing here, we're going to do a lot of handwork and a lot of trimming, and we're not after a specific weight, we're after a relatively consistent thickness. So I'm not going to concern myself so much with getting the type of tolerance I would need for making a coin or something that was going to be marked with an exact weight. So from now I know I can get somewhere around 10, I'll be real close, and I'll be able to zero in from there. I can probably hit it in this pass. So we're actually at 53. I'm actually going to be okay with that. Little heavy's not going to hurt anything because we've got some forming to do. But on this piece, I'm just going to take a little bit of a fraction to get closer to that 52. Measurement on that one. Now it's still at around 53, but I'm going to call that good. Because if I was really trying to hit that 52, I'd have to manipulate the rolls a little bit. And if I were making a marked piece of weight, I would finagle that until I got the exact thickness, because that thickness is going to determine the weight of the piece as it gets blanked out.
All right, I hope you enjoyed that. And if you have any questions at all about the process that we've just shown, be sure to put them in the comments down below, and we'll try to answer them as we can. And remember to subscribe if you haven't already. You can like us on Facebook and Instagram, and be sure to visit our website at landispix.com.